Okay, so at pH 7, carbonic anhydrase exhibits a kcat of 600,000 times a second. Notice that's a really fast one, right? It's one of the fastest enzymes ever recorded, so it's very fast. Estimate the value expected for kcat at pH 6. Okay, so there's kind of two different things that are going on here. So first off, you have to understand what is a rate constant, right? So rate constants, typically they were represented by rate equals K times the concentration of your reactants, right? And they'd be to a power that's not your the number in front of the reactant, right? That wasn't that. Okay, those were orders. You only can figure them out experimentally. Okay. However, in almost every biological reaction, the orders are almost always one. So, what does it mean to go from pH 7 to pH 6? What are you doing to the concentration? You're making it more acidic, but what are you doing to the H plus concentration? It's raising, but by how much? A factor of 10, right? Each pH unit is a factor of 10, right? So it's 10 times, right? If you went from pH 6 to 5, that'd be another 10 times. And so, yeah, 3 pH units would be 1,000, right? Okay. Well, what does that mean for this then? Well, you changed your concentration by a factor of 10. This is sort of the easy logic way to do this. Almost all of these things are always order 1. So it's actually a pretty safe bet. You're very likely to get it right on these things if you just divide by 10, right? Because what you're looking at is carbonic anhydrase. But let's go ahead and do it the correct way real quick. Okay. So the kcat at pH 7 is approximately 600,000, that's 60,000. What's going on there? Yeah. Anyways, the presence of OH minus ions, they miswrote it in there. I mean, they have the right one down here, so. Yeah. Promotes the conversion of carbon dioxide. So in this reaction, you're going to have OH minus. It's going to promote the conversion of carbon dioxide to bicarbonate by the carbonic anhydrase, right? So what is it depending on for reactants? But OH minus, right? Needs the OH minus. So at pH 7, both the concentration of the OH minus and H plus, right, are going to be 10 to the negative 7. Okay? At pH 6, the concentration of H plus will go up by a factor of 10, so 10 to the negative 6, right? The concentration of OH minus, on the other hand, will go down by a factor of 10, right? And so that would be then 10 to the negative 8, right? So you're taking one of your reactants and you're dividing it by 10, aren't you? By going from pH 7 to pH 6. So what is that going to do for your rate? Well, if you divide the amount of reactant that needs to go forward by 10, it's going to cause the rate to go down by a factor of 10, right? Okay. So the two things you need to understand here are that your acid and base pH units, each pH unit is a factor of 10, right? And then you need to understand which direction will this cause it to go. For example, if we went up in pH to pH 8, we would actually increase the speed by a factor of 10. Yeah, exactly. That making sense so far? One of the ways you can help yourself remember this is the conversion of carbon dioxide to bicarbonate, literally carbonic anhydrase, right? Removing hydrate. from carbonic, like carbonation, right? Okay. And so this is going to involve a base to remove the carbonic, right? And so the base is reactant, meaning that the more basic, the faster, right? Less basic, more acidic, slower. That making sense? Okay, very good. Does anybody have any questions or anything?